All right, so I want to start with some basic definitions, okay? And then we'll also talk about some characteristics of stuff. So, what's a polygon? Oh, look at that. That's not on. So the microphone was not on, so now it is on. So let's talk about this again. So, basic definitions and some context for the new project, which is entitled Polygons and Triangulation, okay? So, what is a polygon?
Shape that has more than 4 sides.
It's a shape that has more than 2 sides, but
Okay. Yeah.
It is any shape that is flat and has 3 or more sides. A triangle is a polygon.
Right. That's fine.
All right, so this is a term from geometry, and it is flat. Okay, so that's kind of important for you guys to understand. Now, one of the characteristics of the Polygonal Forms project is that you can take something and you can take something that is complex in curvature in nature, right, and decompose it down to a series of triangles and polygons to make the form. So any of you that have worked with like computer modeling have seen this in models and stuff of like, say, a dolphin or something like that. So you could have this very sleek dolphin, right? And by using triangles and polygons, you can create the shape of that dolphin pretty darn close. And depending on how small the polygons are, that thing is going to look more and more and more realistic as the polygons get smaller. Okay? So, any questions about that? No? Yes? No, go ahead.
Okay. What is the name of this project? Polygon.
Polygonal and triangulated forms.
Okay. Thank you.
Okay? So, now, one of the things that I want you guys to be aware of is that polygons come in all sorts of shapes and flavors. All right? So, technically, a soccer ball, right, which is composed of hexagons and pentagons, right? I believe it's that combination of the two makes the ball, is essentially a polygonal object. Okay? And it is a very Euclidean object. It's very simple. How many of you guys have seen the stealth fighter? Pictures of the stealth fighter? I can pull up on the screen a little while. The stealth fighter is also a polygonal object, right? But that polygonal object, because of the shapes of the polygons, looks very different than a soccer ball. Okay? Any questions about that? Yes or no?
no, sorry.
No? Okay. So now let's start to talk about the polygons. So I'm going to draw a polygon up here. All right. So if this was a surface, right, that had 4 sides, that's a polygon. Okay? This is also a polygon. Okay. Now, those two things are in some ways similar and in other ways very, very different from each other, right? So if I was to use the word dynamic, and you could only pick A or B as having the characteristic of being dynamic, what would you guys pick? We got an A. We got another A over here and another A. Right? Anybody picking B? Nobody's picking B. Okay. So this has the word dynamic character. Why?
It's not 90-degree angle.
It's not 90-degree
Well,
angles.
it sticks out. Like on one side, it's like very.
This one is static by nature of the fact that it has 90-degree angles. Okay? And it's also static by its proportion. So 2 things that I want you guys to be aware of. The angles of an object, right, are going to contribute to its character. The angles of the vertice endpoints. Okay? And also the proportions of the object. Okay? So, if we take this further and we look at it this way, which of those two forms now at this level would you say is more dynamic? B. The thing that is making you pick B is its proportion. The longer and narrower it is, right, the more that it implies motion or something that's sharp, okay? The closer to a one-to-one proportion that it has, the more static that it looks, the more balanced that it looks, okay? So, let's talk about proportion. I don't know if we've discussed proportion before in class, but we may have. I just can't remember. So a square and a circle both have something in common. What do they have in common?
360 degrees.
Yeah, they do. They are 360 degrees, but so is a rectangle. How about its proportion? What is the length? That thing's toast. Try this one. What is the length to width ratio of a square?
1-to-1.
1-to-1.
Same thing with the circle.
And that is the way that you write a ratio with the, I guess that's a colon in between, the two dots. What is the ratio of a circle? 1-to-1. Okay? So proportions, when you're looking at two-dimensional objects, refer to the length to width ratio. All right? So let me try and put a couple up here. Square. Mr. Villatoro, this should look very familiar to you. Yes.
Why me?
You were in my 141 class over summer.
Oh, yeah.
We went through proportion and ratios and stuff like that. So what's the ratio of this? 1-to-1. Very good. What's the ratio of that? 2-to-1. You see the pattern emerging here? What's the ratio of that? 3-to-1. And finally? Okay. So the longer something gets, right, the generally more dynamic that it is going to have as a figure. Okay? All right. Now, the next thing I want to do is to talk about the meaning of angles. All right? So I think I'll just do it right here. So I'm going to put up 3 angles here, and I want you guys to name what they are. Okay, so what are those? How do you name those? Let's start with the simple one, right in the middle.
It's a right angle.
That is a right angle, correct. Right angle, R-I-G-H-T, not W, but as in Frank Lloyd. So what's the number that goes here?
90.
90 degrees. Okay, all right, what is this called?
Acute.
Acute. And I'm not quite sure how to spell that. How do
A,
you spell it?
A and then Q.
A what?
A and then Q. C-U-T-E.
Wait, A-C-Q?
T. A-C-U-T-E.
A-Q.
A. Q.
One person.
Yes.
Cute?
There you go.
That is so cute. This one?
That's not
Obtuse.
It looks like it's.
Oh, wait, no.
It's still a cute. You know what? I screwed up. That's my mistake. You're right. I gotta go this way. Now what is it?
Obtuse.
Obtuse. Okay? And so what is that?
90 or more degrees.
It is greater than 90 and less than 180. Okay? Greater than 90, less than 180. This one, right, is less than 100 or less than 90, right? And it is less than 90 and it is greater than 0. Okay? That makes sense? Okay. Of these three, which one of these do you think is going to contribute to a sense of dynamicity in an object? Which one is least likely to contribute to a sense of dynamicity in an object?
Right angle.
A right angle. Correct. This is the most stable of them all, right? So then this one might give less of an appearance of dynamicity than this one. The reason I'm bringing all this up is that very often, as you're designing something, you have to kind of use an idea of the character of the object, right, to kind of communicate something about what you're designing. So if you're trying to do something and the goal of it is that it looked dynamic, then you might start to think about longer proportions and lots of acute angles. If you are trying to design something that looks stable, you might want to use shorter proportions, closer to 1:1, right? And use more right angles or a larger combination of obtuse angles. Okay? So when you think about a figure like a hexagon, right? It has edges that it has a proportion of 1:1, right? And it has edges that are essentially most or all obtuse. Okay. All right. Any questions about that? No? So hopefully I can get my factotor to develop a quiz on that topic. I haven't done it yet this semester. You're all going, yeah, right. Yeah, right. We'll see.